Hi, Mr. Hugh.
How's it going, Maria? How are you doing?
Good. Mr. Hugh, I had a question.
Yes.
So I was absent on, I think it was Monday.
Yeah.
Um, and I saw that we had like notes or something. And
Mhm.
I asked around like to see if like some of my friends could had help me out with the notes, but like no, like none of them did it, I guess, or something. And I
Uh,
and I wanted to know if like I could like get them or I don't know.
how's it going, Maria? How are you doing? My bad. All right, so sorry, I'm sorry. That was my live stream for this
It's
class.
okay.
Okay, so I have. I don't think I have a filled out version of it. Do I? I think I do. But anyway, the note sheet is on Canvas, and then and then the class was recorded, so you can always just go back and just like watch it and then take notes on there. Everything is also on the slides too. Um, so everything you missed, the note sheet, the slides, and the recording are all available, so you should be able to see what you missed.
Um, where can I find the slides?
The slides are on Canvas. They're just called speed and velocity slides.
Okay, awesome. Thank you.
Yeah, and then the notes are also under it. It's called speed and velocity notes. So that's a note sheet that you can use to fill it out. Everything on the note sheet is on the slides. Like it's almost like a lot of I just like cut and paste like the slides onto the note sheet. So if you just so you should be able to find everything on the slides. And you can always just also watch the YouTube recording as well if you want to like see me go over everything as well.
Okay, thank you.
Yeah. Okay. Hello, everybody. Okay. So, physics today. So, what I thought we would do is thought we would start a little bit of a graph. Um, I know we didn't quite get to cover this a lot on Monday, but I do want to try to see if we can at least attempt it and see if we can figure some things out. So we have a graph here. This graph is a position versus time graph, position versus time. And what we want to do is and there are four sections labeled, section A, section B, section C, section D. Our goal here is to figure out what is the velocity at each particular section. Now, to give you a hint, the velocity is our displacement over time. In other words, it's the rise over the run for each particular segment. So if you're not sure how to do this, you can just take the rise, in other words, how much did the segment go up by, and divide it by the run, and then you can figure out the velocity for that section. So we'll take a few minutes to try to figure out the velocity for each particular section. And then afterwards, I will go over it just because I haven't really talked about it a whole lot. And then what I'll also do is I'll also show you how the velocity versus time graph would look like, because that's also going to be important. So we'll take a few minutes to try to figure out the velocity for each section. Just remember that the velocity is the change in position over time. In other words, it's the displacement over time. So if you can figure out how much the position changed by over what time, you can then figure out the velocity for that section. And whenever ready, just put your answers in the Zoom chat as usual. So for example, for section A, you can think about how much does section A go up by, and then how much does it go sideways by? Because the velocity is the change in position over time. So going up tells us how much the position increased by, and then the x tells us how much the time changed by. So then we can figure out how much position changed, how much time changed, and that will allow us to figure out the velocity. If you're not sure how to do this, so the velocity tells us the slope at any particular point. So if you want to find the velocity for section A, we can find the slope of this section by looking at the rise, how much it goes up by, and how much it goes sideways by. All right, so for A, how much does it go up by? Well, it starts at 1 and ends at 3. So what would the rise be? And then for A, what is the initial x? What is the time it starts off with? What is the final time? And then what is the... Got a couple ideas so far. See if we can get a few more. If you're unsure where to start, you can think about first off, right? How much is the velocity? If you remember, is the change in position, the displacement over the change in time. So we can first define our velocity. We're finding the slope at any point. So if we know the change in position, we know the change in time, we can divide the two to figure out the velocity. And the velocity is going to be different for each one of these 4 sections. But we just know how much it changes by, we figure out the velocity. I'll go over it in a few minutes. I do want to give everyone a chance to figure it out. Okay, so what I'm first going to go over A, and then I won't go over the rest yet. I'm going to first go over A just to show you how we can do this. For A, what we're looking for is we're looking for the velocity at this section here. So the velocity, right?
is the velocity is our displacement over time. What does this mean? Well, velocity is also just the slope of this graph at this point. So for A, what is our displacement? Well, if we start off at 1 and we end at 3, our displacement is just 3 minus 1. And then what is our time? Well, we start at 0 and we end at 4. So our time is 4 minus 0. Our displacement here would then be 2 over 4, which is just 1 half. So how did I do this? Well, we went up, in other words, a rise, we went up 2, and then we went right 4. So our slope would just be 2 over 4, which is just 1 half. This is more of a conceptual understanding here. Our initial position is, our final position is 3, our initial position is 1, so our change is 2. Our final position for the final time is 4, our initial time is 0, so I mean our change in time was 4. So that's how we can do the first one. We'll take another couple minutes just to try to work through this. We already have a few ideas so far. And then I'm going to go over B and D next. So B and D are kind of interesting. They both go horizontally. If you're on a displacement versus time graph, if you're going horizontally, it means that your position is not changing, right? Your position is not changing. If your position is not changing, right? There's no rise. You're not going up at all, which means that your velocity is just 0. And if we look at our rise over run, well, our rise is 0 because our position didn't change at all, and then our time was just 1. So for both of them, the velocity is just 0. And you know that for any horizontal line on any position versus time graph, your velocity will be 0. And then I'll go over C here. For C, in this case here, well, I'm good. So for C, this whole line has the same slope. So let's take a look at the slope here. Well, our final position is -6. Our initial position was -3, or was +3. And then our final time was 8 seconds. Our initial time was 5 seconds. So this makes -9 over 3. So our slope is -3. That means our velocity is -3. I just took out the slope here. It goes down -9, goes to the right 3. So our slope is -9 over 3, which is -3. So that's the gist of how to find a velocity from a distance position versus time graph. You're really just looking at the slopes. You're really just looking at the slope. And for any particular section, it has the same slope, same velocity. But when your sections are changing, you're going to have different velocities. You're going to have different slopes. So we're going to take a look at that later on today. What I also want to do is I also want to quickly. Oh, I didn't even hold on. I didn't even show it. I thought I did. Okay. Yeah. So what I did here is I took the change in position, which is -9. We started at 3 and we went to -6. So our change in position was -9. Divided by change in time, which is 3. So our final velocity was -3. Yeah. I think another thing that's also going to be important is being able to draw a velocity versus time graph. So what I'm going to do here is I'm going to show you how you can draw a velocity versus time graph. I mean, we already did pretty much all of the work for a velocity versus time graph. All we're doing here is we're just plotting the velocity at any particular section. So for the first 4 seconds, here, our velocity is just 3. Velocity was 1/2. Velocity is 1/2. So for the first 4 seconds here, our velocity is just 0.5. This is one horizontal line here. Between 4 and 5 seconds here, our velocity is 0. So we have a horizontal line at 0. for the next 3 seconds, our velocity is -3. So it's going to be a horizontal line down here. It's horizontal because our velocity is always the same throughout the segment. So here my velocity is -3. Here my velocity is 0.5. Here my velocity is 0. And then after 8 seconds, h9, it's also 0 again. So it's just good for velocity versus time graph, right? As long as your velocity is constant within a section, your velocity graph is going to look something like this. So we'll have a little bit more practice later today in terms of looking at velocity versus time graphs. But you're really just looking at the velocity at any particular point in time for position versus time graph. Does anyone have any questions? I feel like I went over it quickly, but does anyone have anything you want me to go over? Okay, so here's what we're gonna do today. Today what we're gonna do is we're gonna do this. Oh, first off, let me go over. For our finals week, we're not gonna have a final in this class because we're not having a final in this class because as much as I trust all of you, I don't trust all of you that much. So it just doesn't make sense to have a final. Instead, it'll be a free period. So I'll have some physics Jeopardy planned, so we'll have some fun. But if you need to do some work, if you need to catch up some work for this class, or if you need to study for another class, you're more than welcome to use the period for that as well. But I do expect you to show up at the very least. Yeah, that is the expectation. But yeah, it should be pretty chill. Because we don't have a final, we don't really have anything to focus on for finals focus week. So the next 2 days after today will also sort of just be, we won't learn anything new, and we won't have any new assignments. We'll just continue working on the assignment that we're going to do today. It's sort of an assignment, but I guess it's more of kind of an activity. It's fun. It'll be interesting. So yeah, that's the plan for the next few days. So I'm going to introduce our assignment for today and the next few days. It's on Canvas. It's called a Codenames Velocity. So if you've ever played Codenames before, basically what happens in Codenames is that you have like one person who has like what you're trying to guess. Then the other person is trying to guess it. You have a guess and you have a guesser. And the idea is you're sort of like piecing together stuff. This is sort of based around that. It's more of like a puzzle. Each person has one piece of the puzzle here, and you need to work together to try to piece together which story goes with what table, graph, calculations, etc. So I call this Codenames Velocity here on Canvas. I'll also put a link in the chat right now. So this is going to be a group assignment because this just won't work if you do it by yourself. I mean, well, you can do it by yourself, but it sort of defeats the point of this. It's supposed to be a collaborative activity / assignment, and I think that's part of the fun of it. So what's going to happen is this game supports 3 to 5 players. There's a lot of different ways you can have a number of players. Each person can have a different role or a couple of roles depending on how many people you have. But yeah. So what's going to happen is you're going to be given a bunch of written stories. You're going to be given a bunch of tables. You're going to be given a bunch of graphs, and you're going to be given a bunch of calculations. Each person is going to have one piece of the puzzle. So in other words, one person is going to have some stories. One person is going to have a bunch of calculations. One person is going to have the table. And the idea is that each person can only see their assigned roles as Google Doc. And the master document that you're going to use to submit the assignment. So you're going to have one assignment that you're going to use to submit it. So you're going to make a copy of this to fill out and then submit. And everyone gets to see that. And everyone else gets to see their own assigned roles as Google Doc. So you can't. So the idea is you don't see everyone else's. You just see your own. You just see your own Google Doc. So what's going to happen is you're going to go try to compile all of the individual components for each story. You're going to try to match the story with the graph. You're going to match a graph with a table. Match the table with the calculations, and then you're going to try to cut and paste around these stories as needed, and you're going to move around elements as you're compiling more stories. Each story, you're going to have 5 things. You're going to have a written story. You're going to have a table. You're going to have a set of calculations. You're going to have velocity, and then you have a display. So I do want you to read every problem very carefully. Everything is very carefully worded. Each and the individual components, I want you to observe them very carefully. There are very slight differences in graphs and tables that are very crucial. So it's going to be easy to just overlook the small details, but be very careful with how you are observing and reading these problems and the graphs and tables and stuff. So there are 5 roles here. You have a spy master, you have a cryptography expert, you have a forensics expert, you have an intelligence operative, and you have a counterintelligence operative. Each person here has a different role here. If you have 3 players, you're going to combine the 2 people are going to have combined roles. You're going to have a spy master combined with a forensics expert, cryptography expert combined with a counterintelligence operative, and then you have intelligence operative. And for the 4 players, the roles are also written here. So you're gonna have 5 people here. The spy master, they are gonna have access to the written stories of each puzzle. And so the written stories are gonna look something like this, where you have a bunch of stories here, all related to spies and stuff. So you have a story, and there's 10 stories here, and then the spy master has access to these stories. No one else can see them, and then you're gonna try to figure out which graph and tables go with each story. So that's what the spy master is, and the link is in here. The next person, the cryptography expert, they're in charge of handling the distance and displacement tables. So here, for the cryptography expert, you have these tables that have different values of distances or distances. This should actually be displacement, really, but it's a bunch of distances, and then you have a bunch of times here. And you have to try to match these tables with, you're gonna try to work together to match these tables with the stories. And then you have calculations. The forensic expert has access to velocity and speed calculations. So there are a bunch of velocity calculations and speed calculations for each story that you have to try to match each one with a different story. And then you have a set of displacement graphs and a set of velocity graphs that you're also going to try to match as well. As you're going through this, you're going to try to cut and copy and paste each image for like each set of stories together. So you're going to put like your. So I'll actually give you an example. I need a key for this, but it should. So when your finished product should look something like this, where you have a story, you have a table, you have calculated, you have a velocity, and then you have a displacement graph. So it should look something like this in terms of your final product, and you're just copy pasting all here. Okay. So the key thing is that each person is going to only be able to see their own Google Doc. At no point should you ever just it's also an honor system thing. At no point should you see anyone else's Google Doc. You should only have access to your own. Eventually, you'll start to see what other people like as you're cutting and pasting stuff from your Google Doc into the master one. Eventually, you start to see like every single like table and graph and stuff. But in the beginning, you should pretty much have no idea what the other people are looking at, and you have to try to communicate, work together, figure things out. Yeah, no one can do this by themselves. You each have a very important piece of the puzzle, and you need to try to figure it out. So yeah. Does anyone have any questions about this? I feel like there's going to be a few questions. Okay, so what I'm going to do is I am going to open up the breakout rooms with your groups, the ones you've been working with, and then you are going to try to figure out which these different stories, you're going to try to piece together the puzzles and figure out which graphs and tables and calculations go with which stories.
Okay, so we have a minute left, so I'm gonna wrap up here. We're gonna pick this up next week. And we will have next week, so we'll keep working on it. It is gonna be challenging because there's a lot of ideas here. It does require a lot of teamwork, but we will pick this up next week as well. No homework other than to keep revising stuff you need to revise or submit any missing assignments. I just want to reiterate that, yeah, this end of the semester is coming up, so you should submit anything you haven't already. If you have any questions or any graded assignments, you should also let me know so I can answer them as soon as possible. I should be mostly covered with grading as of yesterday. I might be missing one assignment that I haven't fully graded yet, but everything else should be up to date. So just keep working on your assignments and revising them. And then we will pick up where we left off on Monday. Other than that, have a nice weekend, and I will see you all on Monday.
Thank
Mr.
you.
Go ahead.
For the notes that we did last class, you said that we were gonna like pick up where we left off. Should we just
Oh.
submit them as they are?
I think what I sort of did is I ended up just combining with the warm up. So you can just submit what you have, because I ended up just combining with the warm up and just sort of covering it in one thing.
Okay.
Yeah.
Thank you.